Good morning everyone. I am Revati, Assistant Professor in the Department of Artificial Intelligence and Data Science, Ramco Institute of Technology, Rajapalayam. Today we are going to learn about an important topic in data science called Facets of Data. In the modern digital world, data is generated everywhere from the social media platforms and emails to mobile applications, sensors, online shopping, and even smart devices. As future data scientists and engineers, it is important for us to understand the different categories of data because each type requires different methods of storage, processing, and analysis. Data can be classified into several categories depending on its structure, format, and usage. The major categories are structured data, natural language data, graph-based data, streaming data, unstructured data, machine generated data, audio, video, and image data. Each category has unique characteristics and challenges. For example, structured data is easy to store and analyze. Unstructured data is more flexible but difficult to process. Streaming data arrives continuously in real time. Graph data focuses on relationships between entities. In the next slides, we will discuss each type in detail. Structured data. Structured data is the most organized form of the data. It follows a predefined format or data model and is usually stored in rows and columns. Some of the examples are student records maintenance, employees database, banking transactions, Excel spreadsheets. Then the structured data is easy to store, search, query, and analyze. Databases such as MySQL, Oracle, and PostgreSQL commonly store structured data. To manage this type of data, we use a language called Structured Query Language, that is SQL. For example, in a student database, we may have fields like student ID, name, department, and marks because the format is fixed. Then the computers can process structured data very efficiently. This slide also mentions hierarchical data such as a family tree. This type of data follows parent-child relationships and it can also be represented in a structured format. Then the structured data is widely used in the industries because it supports fast querying and accurate reporting. So this is the example what we are discussing. This slide shows the example of structured data. We can observe that the information is organized in rows and columns. Each row represents a record and each column represents a specific attribute. This tabular structure makes it easy for software systems to filter the information, to perform calculations, to generate reports, and to analyze the trends. This is one reason why structured data remains highly valuable in business applications. Now let us move to the unstructured data. Unstructured data does not follow a fixed format or predefined model. Some of the examples include in the unstructured data is emails, social media posts, documents, PDFs, images, and videos. Unlike structured data, unstructured data is difficult to organize into rows and columns. This slide gives the example of emails. Although emails contain some structured elements like sender name, subject, date, the actual message body can vary significantly. For example, if a company wants to identify customer complaints about an employee, different customers may refer to the employee in different ways. This makes automated analysis challenging. However, unstructured data is extremely important because most of the world's data exists in the form. Modern artificial intelligence and machine learning techniques help to extract the useful insights from the unstructured data. Next one is the natural language data. It is a special category of the unstructured data. It includes the human languages such as English, Tamil, Hindi, French and Chinese. Some of the examples include in the natural language data are chat messages, news articles, reviews and voice transcripts. Processing natural language is very difficult for computers because human language contains ambiguity, grammar rules, context, emotions and slang. To analyze this type of data, we use a field called natural language processing or simply is called as NLP. So the natural language processing techniques are used in the applications such as chatbots, Google Translate, voice assistants like Siri and Alexa, sentiment analysis in social media. And this slide also mentions some of the tasks: entity recognition, topic recognition, text summarization, text completion and sentiment analysis. One important challenge is that models trained in one domain may not perform well in another domain. For example, a model trained on movie reviews may not work effectively for medical reports. Machine generated data. It is automatically created by systems and devices without direct human involvement. Examples of machine generated data includes web server logs, call detail records, sensor outputs, network event logs and IoT device data. Today, huge amounts of machine generated data are produced every second. For example, a website records user visits. Smart devices generate sensor readings. Mobile towers record call activities. This data is generated at very high speed and in very large volumes. Therefore, analyzing machine generated data requires scalable technologies such as big data platforms, cloud computing, distributed storage systems. Organizations use this data for performance monitoring, fraud detection, security analysis and predictive maintenance. Machine generated data plays a major role in modern analysis systems. Next one is the graph-based data. It mainly focuses on relationships between objects. A graph consists of nodes or vertices, edges or connections. For example, in a social media network, users are nodes, friendships are edges. Graph data is useful because many real-world systems are relationship-oriented. Examples involved in the graph-based data is social media networks, transportation systems, recommendation systems, and internet connections. Some of the graph-based analysis helps answer the questions like who is the most influential person in a network? What is the shortest path between two locations? Which products are connected through the customer preferences? This slide also mentions graph databases and query languages such as SparkQL. Graph databases like Node4j are specifically designed to store and analyze connected data efficiently. This type of data is becoming increasingly important in artificial intelligence, cyber security and recommendation engines. Next one is audio, video and image data. So these data are highly complex forms of unstructured data. So examples involved in the audio video data, photographs, CCTV footage, medical scans, voice recordings, movies, YouTube videos, and etc. Humans can easily recognize objects and patterns in images, but computers find these tasks very difficult. For example, identifying faces in photograph, detecting objects in traffic videos, converting speech into text data. To process the multimedia data, we use advanced AI techniques such as computer vision, deep learning, and speech recognition. Then some of the above. Applications involved face recognition systems, self-driving cars, medical image analysis, and video recommendation systems. Because multimedia files are large in size, they are also require powerful storage and processing systems. The next one is streaming data. So it is a data that continuously flows into a system in real time. Unlike traditional batch processing, streaming data that it arrives instantly whenever an event occurs. Some of the examples included in the streaming data is Twitter trends, stock market updates, online gaming events, live sports scores, IoT sensor streams. Streaming data systems must process information immediately because delays can reduce the value of data. Example of streaming data is stock market systems require instant updates, social media platforms analyze trending topics in real time, then smart city system monitor traffic continuously. So technologies involved in the streaming data is Apache Kafka, Spark Streaming, Flink are commonly used for handling the streaming data. Streaming analytics is very important in modern applications that require real-time decision making. So let us summarize what we learned today. Data exists in many forms and each type has unique characteristics. We discussed structured data, unstructured data, natural language data, machine generated data, graph based data, multimedia data, streaming data. So understanding these categories helps data scientists choose suitable tools and analytical methods. As technology grows, the volume and complexity of data also continue to increase. Therefore, learning how to manage and analyze the different types of data is a fundamental skill in data science and artificial intelligence. Thank you everyone for listening. I hope this session helped you understand and different facets of data. Thank you.